Previously, we talked about relational algebra. So we're talking about databases, a relation. This is sort of an abstract concept. And then in the realization, implementation of the database, we often talk about a table. And then relational algebra is just ways of combining tables. So, and then one particular version of one way to combine tables is known as a join, and we're going to start to explore different types of joins in this lecture. We'll just sort of talk about them generally, and then one specific thing called the theta join. Okay, so relational algebra is just ways to combine tables. So we're taking tables, we're taking parts of tables, combining them with other tables. We're doing the algebra of tables. And so the actions are known as the operations. The tables then would be the operands. And we talked about selection. So a row consists of like this intersection of rows and columns. And so selection was picking out particular rows. Projection was picking out particular columns. We can combine them. Then we talked about combining the results of sort of two queries and sort of treating those results as sets and doing some basic set operations of unions and intersection and set difference. And then we talked about this sort of monstrosity called the Cartesian product, where we took two tables and we concatenated the rows and made sort of all possible combinations of that. And we said that wasn't terribly useful, that Cartesian product. But if we added it to our previous idea of selection and projection, picking out particular rows of the Cartesian product and particular columns of the Cartesian product, we could move towards something more useful. And that is what we call a join. So there can be issues with performing these joins because this sort of intermediate step when dealing with a join is the Cartesian product. So there can be some like efficiency issues in querying databases that you sort of got to be aware of. It's sort of, so you can have a query, two queries that are sort of logically equivalent, but one be more efficient, much more efficient than the others because of this sort of intermediate thing being so unwieldy. Okay, so we're going to start thinking about different kinds of joins. We're going to sort of pick out rows and columns. So picking out columns is relatively easy. It's the picking out of the rows that's more interesting because you're going to apply some conditions, some predicates, some way to like make the rows of interest. So we're going to apply some condition, and our conditions are usually something that is true or false. So the theta join is going to be sort of more generically sort of any condition, whereas an equal join is going to be particularly when the join is based on a condition of equality. Then and we'll just keep getting and these first three are just more specific versions. So an equal join is a theta join. Almost any join is a theta join, but then an equal join says that the condition in particular was equality. And then a natural join is like if the equality was the equality of a foreign key matching a primary key, and also we sort of project out the duplication of the keys, and that is moving to what we call a natural join. And then and so far we've been talking typically about what we call inner joins. And then if we start to worry about, well, what about the records that didn't match? And then we might sort of keep them along and get an outer join. And then we also have this concept of a semi-join. But here we're just sort of mentioning all these varieties. In this particular presentation, we're only going to do the sort of generic theta join and get on to the inner joins and outer joins and natural joins in a later presentation. Okay, so the theta join, we're going to have some condition, some predicate, and it's going to be, in general, it could be greater than or equal, any of these combinations. Um, we have greater than or equal to, less than or equal to, not equal to. So uh, we're going to separate out equality and make it the equijoin, but this is sort of anything that's not equality, let's call a theta join. Okay, so we're going to start with some Cartesian product, just combine two tables, have all sorts of things, and then make some restriction. And again, our sort of, we tend to naturally go for the relationships we set up when we built the table of the sort of inner natural join on the foreign key matching the primary key. But let's think about other possible scenarios. So we have some table R, some table S. We're making the Cartesian product, but we're adding some condition F. Um, okay. So I'm going to have customers, and something I track on my customers is their budget, or somehow the money they have to spend. Maybe it's money they have in some account. Maybe I just have some way of figuring out how much money they have. Okay. Then I have a list of items, and those items have a price. And now I'd like to advertise my items to my customers. And so I don't want to bother advertising an item to somebody who can't afford it, and I know they can't afford it. So I want to, have a more directed marketing. And so therefore, I'm setting up a relationship based on an inequality. And I want the person's budget to be bigger than the item. If the person's budget's bigger than the item, they can afford it, and then it's worth my while to advertise it to them. Okay, so here are my silly little tables. Again, I'm showing them in Microsoft Access, but that hardly matters. So here are my people: John Smith, Alice Cooper, Grace Slick, and Bill Gates, and they have different budgets. Okay, John Smith is pretty poor. Okay. And then I have my items, and I have a lawn chair, and that's $15, and everybody can afford it. I have a Hawaiian vacation, and that's 2,500. And then there's a mansion. Okay. So, and I gave them both IDs, and I was a bad database practitioner, and I just gave those field names both the name ID. So when I go over to in Access, if I drag these two tables out in Query by Design, and I'm trying to sort of set up a table, it's going to think those IDs are a foreign key matching a primary key. It's going to try to make a natural inner join out of it. So that's what it assumed. So I dragged out these tables, and it just sort of put this line between the IDs. And it's like, I don't want that. So I need to get rid of that. That's not the kind of join I am making. Okay. So I got rid of that line. I got rid of that join. And then right now, if I just did this without any conditions, I've got a Cartesian product. I've got this whopping big thing. I'm going to put all my people and all the products next to each other, all possible people, all possible projects. That's what the Cartesian product does. But I don't want to do that. I want to select out only those combinations where the person can actually afford the item. So I'm going to, so this, at this stage, no condition, Cartesian product, whopping big thing, all items, all people, whether they can afford it or not. Now let's add the condition. And uh, this is just, this is the Cartesian product, all of the products, all of the people. So John Smith, who was poor, is still matched up with a mansion, though he can't afford it. All right, now we're adding in a condition. And this is an inequality, a less than condition, so it's a theta join. So we're selecting the items with the item name and the person and their name, and we're selecting from the table uh, item, comma, personal budget. So it's not, there are two ways we can have the two tables and some where clause. We can always do that. Um, and then later on, we'll see when it's the equality one, there is, you can use this notation and there's another notation. But for this one, with the theta join, we need just the two tables separated by a comma and the where with the condition. Then when we do later on an inner join, we will see that this notation is available to us, but there is a second notation that can be used to sort of announce it's a different kind. It's the more usual kind of join. This is the unusual kind of join, the theta join, the inequality join. But here we go. Select item name, person budget name from item comma person budget, where the item cost is less than the person's budget. And that was enough to do the theta join. That's enough to figure out, to match up items and persons uh, who can afford it. But I added a group by, and that just is going to sort of help me organize my results. And I'm saying that I want to group by the item name and then the person. So I'm going to have the lawn chair and all the people can afford the lawn chair, and then the Hawaiian vacation and all the people can afford that, and the mansion and the people. So I'm just organizing it by item because I want to send out advertisements based on my items. And so I want it grouped by item so I know what group of people to send out each advertising to. Okay. So here just we are over in access, and I added a group by, and I added a condition, and then here it is. So it just alphabetized. I didn't say sort by the price of the item. So it just figured out, it decided to sort on its own and is sorted by the item name. So Hawaiian vacation, then lawn chair, then mansion. So we see that the Hawaiian vacation, Alice Cooper and Bill Gates can afford the Hawaiian vacation. Everybody can afford the lawn chair, and the mansion only Bill Gates can get. So this is a theta join. We're combining two tables. We are combining it on a condition. That condition is not equality. It is an inequality. It is a less than, and that's what we mean by a theta join. And that's it for this one. Thanks for your attention.